Okay, we finished making our final pass around this part, and we're going to take our original gear and we're going to mesh it with the new gear. And we eyeball at the valley at the new gear and roll it to where we know that we're straight in line with the old gear's valley. And we can see that the gap is larger on the old valley than the new valley. That means that the new valley still needs to be deepened so that we'll narrow up the tooth a little bit, and then we'll see that even out. Now, how much more? Let's bring you out and we'll take a look at a few other ways of measuring up this gear. Okay, one of our measurements is taking large dial calipers here and coming across here and measuring straight across valley to valley and comparing it to straight across valley to valley on the old gear. And we're getting about 4,785 there, and we're getting 4,750, I believe here, 4,750 there. So we're about 30 thousandths of a difference in that way of measuring. The total depth of gear, the book said 134 and 8/10, and I have a depth mic here with a nice flat blade. And we'll back this off a little bit here because I forget where I was at, but it lets me come in and lay flat against two teeth there and then get it to go down into the bottom. When I get down there close, I kind of move the base around again here, just making sure that I am as centered and rock bottom as I can. All right, and this is 131. All right, and we'll back this off here, and we got 119. Okay, it shows less difference between the two depths here than the depth of this now and what the book calls out. By the book calling out, we would take 16 more off of here. By our dial here, we went into 120 and it says 134. That would be like 14 thousandths. So 14 to 16 thousandths would be put as far as our dial going to full depth there, matching up to get that. The measurement of root straight across kind of gives us real close to that dimension as well, but from 85 to 750, that's leaving you about 35, you know, is almost 17 or so in that realm. So I'm going to go ahead and dial in another 15 thousandths. Now there's another method of measuring here and kind of comparing, and it's not a formulated measurement that actually can be a calculatable measurement. It's only a comparison measurement, and that is using thread wires. And of course I don't have a thread wire that would match exactly at the center of the meeting of the addendum and dedendum area, the working diameter or circular pitch there exactly, but I have two wires here that are 100 and these were 108 thousandths, and that working diameter is like 92, something like that. 98, and I just didn't have wires in there, but these actually protrude a little bit above, and you can get your calipers to fit over those. And I measured those in there, and I go straight across here, and on this gear here I'm getting 5 inches and like 42 thousandths. And if I take and I put 2 marks here so I can easily get this set up here. And I'm getting like 5 inches and 26 thousandths there. So we do have about 15 thousandths thereabout, close, give or take a thousandth of difference there. But our depth is almost double that. But we're reading on the actual pitch or the working area of the tooth. It can go deeper, but that's not going to go that much narrower. So we're going to be paying attention to what that's going to be after we do this. We'll see what our wires actually give us in relationship to them as well. Just a note. Okay, we're set up and ready to go. Here we fire out the machine. Okay, and I'm going to go ahead and dial in and come into our 34. Okay, that's 34 and a half or so. And we're locked down. All right, our final cut pass around. And we might be able to speed up our travel feed for this process here. I'm going to go ahead and increase it to 1 3/8 inches per minute. Not that we're racing through it, I want to check the finish of the tooth of the cut itself. All right, we got to put on our fan because the humidity's killing us again today. Okay, how's the finish look? Finish looks good on there. Okay, let's go ahead and go to the next tooth. There we go. All right, we'll catch you up at the end. All right, checking our width and coming in here. And checking our depth. We're within a couple thousandths of matching this. A couple thousandths on the low side, underside. So we're not heavy anywhere. But we are uniform. And I know that it's not going to be a binding situation. We don't have the rest of the spindle and the rest of the gears and everything else in here to come to play. But by all my dimensions here and comparing to the sample, we have a good gear cut here. I'm happy with it. All right, we're going to pull this out of this mill because I got a couple pivots that I got to bore. And so we got to get this moving. And we're going to take this over to the lathe, and we have a little bit of a raised burr on this edge right here. So we're just going to massage this edge here and this edge here while we have them in there. Just give it a quick spin, and then we're going to be separating this from the arbor, and then we can get our gear blanks over. We'll concentrate on the relief in the center here and the hole pattern, and then the final thing we'll do will be put the broach keyway in the gears. All right, we just put our arbor into the K&T. We had another job working in here, and this was over at the lathe. We had broke the edge, kind of took sandpaper to the edge there, so everything is deburred right now. Now we're going to have to do each and every one of those sections all the way through this on the other 4 split lines there. There's 5 gears here, but there's 4 mating lines of double side. These 2 outsides are done. We won't have to worry about those. All right, I just want to break this loose. And I got the old gear here. We're going to lay out our new gears getting off of here. I hope I can just pull these off of here just as easy as I put them on there the other day. There's no raised burrs, but it does need to be broke on the edge there. It's one of the things that is nice about ductile iron. There's not a whole bunch of rolling over burrs. Other materials sometimes raise that up quite a bit. Well, those are coming off there real nice so far. And look at that, we got the gear train going right now. Yeah, remember those ones that we said were tight? Okay, we may actually just put this, go take it in, put it in the arbor press, and push this out without messing with it. We don't want to create any damage to this. Okay, we just went in there and pressed this off, and you can see those haven't even separated yet. There's 1. There's 2. Okay. Those look good. Nice. Okay, let me finish putting together my arbor here, and we have some sleeves over there I got to put on here, and then we're going to put this away. Okay, we've got these all laid out here, and we're going to get ready to set up a jig that's going to let us come in and hog out the material. We need to hog out this material that's in here. We're going to go ahead and pull out those 2 pivots, and those pivot bolts right there hold the 2 halves of the tapered lock ring. And then the other one is a wedge adjustment that tightens those up. And then these here are lightning holes to balance the this spinning object. This weight of the knob and everything else over here has got to be equalized so that when you're spinning it, and that's what those are, is balance holes. So we just basically put them in the same location and drill the same depth, and we get that drill point as close as possible. So we're removing that amount of weight. All right, we took a slug of steel and one that we had that we could create this nub. So we turned this diameter, which represents the spindle shaft of the lathe, and then a nice face here, and then we relieved it about 1/1000th from about here all the way in there, so that we're going to be making good contact out here. Now the reason why we're doing that is all of our gear blanks, this one here fits on a little bit looser than our other ones. You'll see it because I believe this bore on this one here was worn larger, but regardless, he's going to have a tighter fit spindle. Now I put the 1/2 inch National Course thread in here, because I have a National Course stud, and we'll go ahead and we'll double nut this here so that we can spin these nuts on and off. We got 5 of these things to do, so I just want to give it a quick tension so that it doesn't follow us out, especially once it gets the dust on it from the ductile iron. Okay, it doesn't need to be a whole bunch, just so that we know that it's not going to come off with spinning the nuts on and off. Alright, we set that down below this surface so that we had draw. Draw is just the fact that it'll never meet up and there'll be a gap in there because of the pressure. And there, again, we have a slug, leaves this clearance in here to come in and machine this, and we'll be testing out that. We're getting ready to set up our tool bit here. So we'll go ahead and put this in low here so we just lightly tighten it for the setup here. And let's go ahead and spin that up. And you can see that this is running true, that's running true. And we're coming in here to machine the relief in here. And we need to have it flat bottom because we have nuts and a thrust surface for the adjustment nut that we remove from here. And on the other side is the 2 shells that slide together. Alright. Alright, so now we can go ahead and set up our tool bit. Now, I just happened to find a piece of carbide in the box there. This is an old Case 68 Kennametal AL8, and it had a radius on the bottom, but I kind of flattened it off, and then I adjusted the radius on each side to match pretty close to the radiuses for the inside diameter and the outside diameter, so that we'll be able to come in here like this and like this. What I'm going to do is go ahead and mount this tool bit into my holder here, set the height, set the position, and then I'll be able to come in and I'll set my dials with a Sharpie mark. Boom for inside, boom for outside, and the travel dial plus another dial on my ways over here for the total depth. And then we're going to blanket this up, and then we're going to come in and we're going to plunge in and cut this relief in each one of these. Okay, I've got the tool bit in there now tightened down and the height set. I brought it into the bottom, so I have 0 set here, 0 set here. Going in, I have a line here, and my 0 is my mark there. If I come out against the outer side there, I have another felt marker marked right by my ways here, and I have the blue spot on my dial. And that's all I'm going to need to go in and whittle out this pocket. So as long as none of those get bumped or moved, I'm in good shape here. All right, so let's go ahead, back this off, and let's get the first part in here. All right, we're just going to be spinning this off, pulling that off, and we're going to be just changing out the gears. All right, we're just going to grab the first one off the end there. Now I did undercut it really down in here, and like I said, I took a thousandth or 2 off of this surface right here, but I gave it a real little bit of relief down in the bottom there because I want the sharp edge of the gear to set flat without any interference. Okay, and that fits on there really nice. No play, no slop. A little tighter than the original gear. Alright, and put this in low gear here so we can crank a little bit of tension on here. Okay, we're good. Alright, put it in another gear. Let's spin her up. Looks really nice. Let's put an indicator and let's see what we're running across the top of the gears here for curiosity. Okay, I got my indicator set up on here, and you can see that you know, between each teeth, it's gonna fall and come back, fall, come back. Okay, because I don't really have a whole bunch of spring pressure on here because I just want to barely be there with the indicator. Okay, let's come up on a high one here. And I'm not going to try to set it at 0 because it'll change no matter what. I just tried to set it on 0 a minute ago and it wouldn't. So we're minus 1.5 there. We're minus 1/2 there. We're minus 1/2 there. Minus 1.5 there. All right, so we're within 3/4 of a thousandth, 1/2 to 3/4 of a thousandth on center. I'm happy with that. Okay, now we're gonna go ahead and we're gonna touch off. I got this set on a low speed here, so we're not flying a whole bunch of debris all over here. Now I'm gonna go ahead and I'm gonna plunge in here. Now from our 0, we're about 100, 210. 210 thousandths that we need to come in. I'm going to plunge in about 50 thousandths here. That's 40 and we're starting to get a little sing. So I'm going to come on out. I'm just feeding by hand. This is all going to be hand work. It's going to be a hand job. Another 200 coming out. All right, and we're going to stay about 10,000 shy from where we want to go. We're going to come on in. All right, we're touching up with air. Both directions seem to be really cutting fine. Okay, we're coming up to our 0 and we're 10 shy of that. All right. Now we could just go ahead and plunge in on our inside or our outside. We're going to come in just a little bit here. That was like another 40. 40 seems to be the sweet spot before it starts shattering. That's peeling them off pretty good, and they're not really flying all over the place. They're staying right up here on the top. Most of them are getting caught by that towel or this t-shirt we have down there. All right, now I'm just going to come in a little bit. I'm just going to go ahead and take the next 40 here. It'll take a little bit more on the side cut there than it will on the plunge. So there is 10 away from our diameter there. Here we go. We're plunging in again. We're about 110 or so away from our final depth there. All right, there's about 10 away from there. And there's 10 away from there. Okay, we're about 50 away from the final. Ten away from there. Okay. Both dials say we're 20 away from the final. I'm going to come out to our 10 there. All right, now I'm going to feed on in. And there's a 10 there. Okay, now I'm just going to give myself a little clearance here. I'm going to get the depth mic and we're going to go ahead and check our depth right now and compare it to the sample. Okay, I just measured the depth over there on the part and measured it here, and I had 7 thousandths more to go to match up. But I have a little bit of a burr here and a little bit of a burr here, and I think we're actually holding ourselves out a little deeper than we want to. On my travel dial, both of them here, I have between 7 and 10 thousandths to go. And so I'm going to go ahead and I'm going to go into my full diameter, or my diameter to the minor diameter, and then come down to my face, come out, and then come out on my major diameter. Here we go. Come into my 0. She wanted to chat a little bit, so I'm going to come out just a little bit, come into that depth here. Okay, both our dials are to 0. I'm going to come back into that 0. There we go. Now it's a nice looking radius in there. Okay, I'm going to slowly just face on out. A nice broad face on that, so it leaves a pretty nice finish, even though I'm hand cranking it. Pretty aggressive feed. Okay, we're coming up. There's about 7 thousandths from being finished. Okay, I'm going to come on out. Because I want to come out to that diameter and then plunge in. Okay, right there's our diameter. And we're coming up. And there's our 0.